You know that feeling when you hold a brand new, perfectly machined product? The weight is just right, the finish is flawless, it's just, well, a piece of art. But then that sinking feeling hits when the first scratch appears, right? So how do we keep that perfection from fading? Let's dive in and find out.
I mean, it's so frustrating, isn't it? That amazing new phone gets a scratch, or that beautiful tool starts to show signs of rust. So what's the secret? How do you make that brand new feeling actually last? Well, it's not magic. It's actually some incredible science happening on a scale you can't even see.
So here's what we're going to cover today. We'll start with the problem, that fragile finish. Then we'll get into the solution, engineering some invisible armor. We'll look at how we get strength from the surface, how we fight off decay and wear, and even how to give surfaces some amazing superpowers. Finally, we'll wrap it all up with the art of durability.
All right, so let's start with the problem itself, that fragile finish. You can have the strongest, most perfectly engineered material in the world, but it's got an Achilles heel, its surface. That's its front line, right? It's where it meets the world, and it's always where the first tiny scratches and the first signs of rust start to show up.
So how do we fix this? The answer is this incredible field called advanced surface engineering. And really, the best way to think about it is like giving a product a suit of microscopic armor. You get to keep the lightweight core, say aluminum, or the brute strength of steel, but you add this paper-thin, super high-tech layer right on top that just changes the entire game.
And the difference it makes is just, well, it's night and day. On one side, you've got your standard, untreated material. It's vulnerable, it's going to get damaged. But on the other side, you take that exact same material, give it an engineered surface, and suddenly it's like a fortress. It's stronger, it laughs at rust, and its look and function are locked in for the long haul.
Okay, so let's dig into that first line of defense. Protecting against the physical world. You know, the bumps, the drops, all the inevitable scratches. How exactly do we engineer a surface that's tough enough to handle, well, real life?
Okay, so one of the absolute coolest techniques for this is called laser cladding. Just picture it. A super precise laser beam is literally welding a brand new ultra-strong skin onto a material. It's amazing. Research shows that this process creates this tiny, intricate structure that is just fantastic at stopping those little micro cracks before they can even begin.
Now, it might sound super complex, but the basic idea is actually pretty simple. First, you get the base material ready. Then, a powerful laser zaps a special powder, melting it right onto the surface. And as that cools down, it fuses and creates this brand new, super dense, and incredibly tough protective layer. That's it.
But, we can push this even further by thinking small, like nanosmall. Scientists are now mixing in these tiny, tiny particles, things like titanium carbide and graphene oxide, right into the coatings. And what they've found is that these nanoparticles act like microscopic rebar in concrete. They reinforce the whole structure, making the coating way harder and much, much more resistant to wear and tear.
So how much of a difference does this really make? Well, get this. One study found that a new multi-layer coating wasn't just a little bit better, it was 4 times more resistant to wear than a standard epoxy coating. Not 10%, not 50%, 4 times better. That is a gigantic leap in durability. All right, so we've handled the big, obvious physical hits. But what about the slower, sneakier enemies? I'm talking about the silent killers of product aesthetics. Corrosion, rust, and that constant grinding friction that happens day in and day out.
And really, what it all boils down to, and researchers in the field agree, is control. It's all about fine-tuning these processes. When you can do that, you can massively boost resistance to both corrosion and wear. And that is the real secret to making products that we can actually count on.
So a key strategy here is pretty simple. You build a wall, a really, really good one. One of the best ways to do this is with a technique called micro-arc oxidation, or MAO. Basically, this process grows a super dense ceramic-like layer right on the metal surface. And this new layer acts like a perfect shield, physically blocking all those nasty corrosive things from ever getting to the metal underneath.
And what's cool is that this strategy isn't just for one type of material. It works all over the place. You see studies improving coatings on steel, others using precision machining to seal up tiny cracks on magnesium, and even some adding glass nanoparticles to build up denser, tougher layers. The exact method might change, but the goal and the result is always the same: way better durability. Okay, this is where things get really cool, because we're moving beyond just playing defense now. With surface engineering, we can actually give materials brand new abilities. Seriously, we're talking about giving them superpowers.
I mean, just think about this for a second. What if a surface could repel water so well that it literally cleans itself? Or what if you could take a material and tweak its surface to either be a better electrical conductor or a perfect insulator, boosting both performance and safety? Sounds like science fiction, right?
Well, it's not. It's happening right now. You've got coatings with graphene oxide that create better electrical pathways, which is huge for stable electronics. And then on the flip side, you have different coatings that act as amazing insulators, preventing dangerous short circuits. It's giving us total control over a material's properties.
And hey, remember that self-cleaning trick I mentioned? That's thanks to something called a super hydrophobic surface. The idea is actually inspired by nature, by lotus leaves. These surfaces are engineered to be so incredibly water repellent that water can't even spread out. It just beads up into little balls and rolls right off. And as it does, it picks up dirt and takes it along for the ride. So not only does it keep things looking clean, it's another great way to fight corrosion.
Okay, so let's pull all these threads together. All of this incredible science happening at the microscopic level has a huge impact on the things we see and use every day. This isn't just lab work for the sake of it. This is about fundamentally redefining what we mean by quality and durability.
And hey, don't just take my word for it. Check out this comparison from a recent study. They put a modern coating up against traditional hard chrome plating, which has been the go-to for protecting industrial parts for ages. The result? The new coating had almost 5 times better corrosion resistance. That's not just a little step up, that's a total game changer for safety and how long things last.
So what's the big takeaway here? It's that beauty is no longer just skin deep. The lasting, flawless look and feel of the products we love? That's not an accident anymore. It's the result of some seriously brilliant science. It's engineered right from the surface inward to last.
And that leaves us with one last question to chew on. As we get better and better at creating these perfect surfaces that resist almost everything, scratches, rust, dirt, what does that do to our relationship with our stuff? What does natural aging even mean for the products of the future? It's definitely something to think about.